Dear students, very good morning. Today we are going to discuss one important problem in transportation problem. Okay, the problem is about to find the basic feasible solutions and optimal solution. Whether the basic feasible solution is optimum or not, we are going to find all those things. So now we are going to see the transportation problem. The problem now we are going to discuss is solve the transportation problem. Solve the transportation problem with unit transportation cost in rupees, comma, demand and supplies or as given below. So I think you have noted a question. This is origin and this is destination. Origin and this is destination. Now you are having the destination, you are having D1, D2 and D3 and A, B, C and D. Now the unit cost is given below. The unit transportation cost in rupees is given in this matrix. Okay, now see the first is 5, 6, 9, then 3, 5, 10, after that 6, 7, 6, after that you are having 6, 4 and 10. The supply units are given by 100, then 50, then 100, after that 75, 100, 75, then 50 and again 75. Here you are having 70, then 80, then 120. So now you are having the origins A, B, C, D and destination D1, D2, D3. So you have to check whether a given problem is optimum or not. So if you want to check this is optimum or not, means you have to add everything, A plus B plus C plus D, whether if it is equal to D1 plus D2 plus D3, the final values of these. If I am taking A equal to, see here I am taking all these are A, this value is how to say this is A11 or it is A1 D1 or it is AD1 AD2 AD3, BD1 BD2 BD3, CD1 CD2 CD3, DD1 DD2 DD3. Okay, but I am just seeing the supply and demand in rows and columns. If these are equal, then you can say it as the given problem is balanced. If these are not equal, then you cannot say that it is that the value or that the given matrix or that the given problem is balanced. Okay, so you have to check this. So now see I am having 100 plus, let us check. Okay, let us check with this value A plus B plus C plus D. Okay, actually, okay, now you are having 100 plus 75 plus 50 plus 75, that is 75 plus 75 is 150, 200, you are having 300. Okay, now D1 plus D2 plus D3, so you are having 70 plus 80 plus 120. that is equal to 200, 270. So 300 minus 270, actually 300 is not equal to 270. So you need a 30 more what? 30 more demand. This is demand, right? This is demand in units. If you want to balance, it means you need to add 30 more in the demand. Okay, so how can you formulate this? How can you write this? I am writing this as sum of origin or sum of demands. Okay, this is what you say, this is sum of supply. Okay, sum of supply, and this can be called as sum of demands. This can be called as sum of demands. Okay, sum of demand. So here I need to add 30 more quantity or 30 more units to demand. Okay, so for that I am going to take the given problem as, see, let me copy this problem like this, control plus C, then control plus V. Let me paste it here. Okay, now we are going to solve this problem step by step. Okay, now erase the unwanted things, because the problem is purely going to be solved only based on the numbers. Okay, so now you want to balance it, so you want to add the 30. So how to add the 30? So to add the 30, you need to add another column. You need to add another column. Okay, now paste it here. Now here you are going to add another column. So the another column is nothing but this is D3, right? This is D3 and this is D4, and here all the values are 0. Okay, and you are having finally 30. Okay, this is 30. So now the given problem becomes balanced. Now the given problem becomes balanced. So now we are having totally how much? See, 80 plus 120, 200, 230 plus 70, 300. Here also 150, 50, 200 plus 100 plus 100 is 300. So it is balanced. Okay, now the problem becomes balanced. Here the problem, initially the given problem is unbalanced. Here initially the balanced problem is unbalanced. So you have to write here number of summation supply is not equal to summation demand. So the given problem is the given transportation problem is unbalanced. So in order to balance it, you are adding the column D4. So add a new column D4 with the demand 30. So you will get the following table. Now the problem. Okay, here summation supply equal to summation demand. So the transportation problem is balanced. Okay, now you have to find the basic feasible solutions. How to find basic feasible solution? So I am repeating the question once again for you. They have given the question: solve the transportation problem with unit transportation cost in rupees, comma, demands and supplies are given below. So they have not mentioned by which method we have to solve it. There are three methods are there. One is north west corner rule. Second one is least cost method. Third one is Vogels approximation method. What I can suggest to you is, if you are asked to solve any transportation problem using northwest corner rule, means you can solve it by using the northwest corner rule method. If they mentioned like solve that problem using least cost method, means you can solve it by least cost method. If no method about by which the problem should be solved is not mentioned, means you can go for Vogels approximation method, because the Vogels approximation method is considered to be the best method to solve the transportation problem. Okay, so now we are going to solve this problem. Okay, now see, now you are having this table, this is unbalanced, and after that you are having a balanced problem like this. Okay, now in this balanced problem you are going to do the Vogels approximation process. So in the examination you have to go with the separate table, you have to draw the separate table below this. Okay, but I am going to do in the same table itself. So before that I shall close all the boxes, without any gap. Okay, without any gap, because I need to fill the colors of occupied cells. Okay, or satisfied rows and columns. I'm going to okay, now I think everything is closed. Yes, everything is fine. So now, so how to apply the Vogels approximation method means, here you have to find a difference between the smallest element and the next smallest element from each rows and columns. You have to find a difference between smallest cost and the next smallest cost in each rows and columns. The difference is called the penalty. Here the minimum cost is 3 and next minimum cost is 5. So the difference is 2. So this 2 is the penalty. Here minimum cost is 4 and next minimum cost is 5. So the penalty is 1. Here the minimum is 6 and 9. So the penalty is 3. Here obviously it is 0. Okay, now here so here you are having 5 and 0 is there, so it is obviously 5. Then everything is like that only. 5, sorry, it is 3. Then it is 6, and this is also, and this is 4. So the maximum cost is, the maximum penalty is 6. Since the maximum penalty is 6, you have to choose this row. Okay, in this row you have to choose the least cost, you have to choose the minimum cost. The minimum cost is 0. The minimum cost is 0. So there you have to assign the minimum of 30 and 50. The minimum of 30 and 50 is 30. So I am assigning 30 here, so that this 30 will become 0. Since this column is satisfied, I am going to I'm going to cancel this column. Okay, so this is hiding a letter, so we shall choose a very mild color. Okay, now this column is cancelled. Okay, now from the remaining quantities you have to find the penalty. Okay, from remaining quantities you have to find the penalty. So here 5 and 6 is there, so it will be 1. Since you have used 30 here, these 50 should be subtracted by 30, so it will become 20. Okay, become 20. Okay, now here the difference is same, right? Is it same? No, it is not same. It is 2. It is 1 and it is 2, right? 5 and 6, difference between 5 and 6 is 1, difference between 3 and 5 is 2, difference between 6 and 7 is 1, difference between 4 and 6 is 2. Here nothing will change on these 3 because we have not cancelled any of the rows. Okay, now see the maximum penalty. The maximum penalty is this 3, so you have to choose this column. Okay, you have to choose this column. In this column you have to pick a minimum cost. The minimum cost is 6. In the minimum cost you have to assign the minimum of this 20 and this 120. So 20 is minimum, so that this 20 will become 0. Now this 120 will become 120 minus 20, it will become 100. Okay, now what is satisfied? This row is satisfied. Since it becomes 0, this row is satisfied, so you have to fill this row. You have to cancel this row. Okay, now you are having the remaining rows and columns. Okay, now again you are going to find the minimum among each rows and the columns, difference between the. Okay, so here minimum cost is 3, next minimum is 5, so 3 minus 5 is again 2. It is 5, 4 and 5 is there, difference between 4 and 5 is again 1. Here 9 and 10 is 1, and here you also have to check. Here you are having, let me write it here. Okay, this is first iteration, second iteration. Since there is no space here, I am writing here. Okay, so otherwise I shall move everything to the, sorry, I shall write the third iteration here. Okay, I shall write the third iteration here. So in this third iteration, the difference between 5 and 6 is 1. Here 3 and 5 is 2, and there is nothing will come here. Here 4 and 6 is 2. 4 and 6 is 2. So you are having 2 here, 2 here, and 2 here, right? So you have to choose the which 2. You can choose any one of the 2. So before that, let me check with the guess. Is it possible to choose any one? Which 2 is possible? It is obviously arbitrary only. You can choose any 2. So without some guess, we should not choose, right? So let me make some guesses. So there you are having 3 and 5 is 2, 6 and 4 is 2. Okay, then it is 5 and 6 is 1. 3 and 5 is 2, 5 and 6, sorry, 4 and 5 is 1. Then 9 and 10 is 1. So here there are There are two 2's, right? Two 2's with the same values. 10 and 10 is there, 36 is there. Let me choose this 2. If I choose this 2 means only one cell will be there in this column wise. I'm having only 1 2. So let me close this. Okay. So here I'm going to choose this 2. Since it is arbitrary, since there are two 2's here, it is not like I should not choose one of these two. But I'm giving preference for this since there is only one maximum cell in the bottom cell. Okay, so I'm choosing this 2. So the minimum cost here is 3. So in this 3 I have to assign the minimum of 70 and 75. So I'm assigning 70 here. So this will become 0. This 75 will become 5. This 75 will become 5. Now I have to cancel the satisfied row. Okay, so this is then this. So now you are having again some rows and columns. So again in this you have to find the difference. So in this again you are going to find the difference. So here you will have 6 and 9. So let me move this thing. Okay, let me move this thing a little right side. Okay. So here I'm going to use it for fourth iteration. The fourth iteration is given by fourth iteration. So here the difference between 6 and 9 is 3. The difference between 5 and 10 is 5. Between 5 and 10 is 5. Then 4 and 10 is 6. Here the difference will not change. The same, it is 1. This cannot be used. So this cannot be used. So difference between 4 and 5 is 1. Difference between 9 and 10 is again 1. The maximum allocation, the maximum penalty is 6. Since maximum penalty is 6, I have to choose the minimum cost here. The minimum cost here is 4. In this 4 I have to assign the minimum of 75 and 80. So I am assigning 75 here. So this will become 80 minus 75 5, and this will become 0. Since this row is satisfied, I have to cancel this row. I have to cancel this row. Okay, now this row is cancelled. Again you have to go for fifth iteration. Okay, I shall write the fifth iteration here. Since there is no space there, I shall write the fifth iteration, the last iteration here. Okay, last iteration. So 6 and 9 is again 3. Then 5 and 10 is again 5. Here the difference is 6 and 5 is 1, and 9 and 10 is also 1. Okay, the maximum penalty is 5. So the maximum penalty is 5 here. So I have to choose this minimum cost. So here I have to assign 5. I have to assign the 5. If I assign 5, what will happen? If you assign 5 here, both rows and columns are satisfied. 2 rows and columns will get satisfied. So if I put 75 here, what will happen means this is also fine, this is also 5. So you will get this and this become 0. Here also you will get cancelled. Okay, simultaneously two things are becoming 0. So this 5 will become 0. Okay, this 5 will become 0, and obviously this 5 is also becoming 0. Okay, now there is left only one element that you should get the equal values. If the values are equal, means the problem solved by you is right. You have solved the problem in a right way. So here you have to assign this 100. If you assign this 100, what will happen? This 100 will become 0 and 0. Okay, so now everything is satisfied. I am going to cancel this also. Okay, now see, now you are going to select this assignment separately. Now we are going to take this assignment separately for our optimality check. Okay, now to check the optimality, we are going to take this. Okay, okay, Control plus C, then you are pasting it here. Okay, okay, fine. Now erase the unnecessary things. Here you are having, okay, see, now you are having, okay, now dear students, watch carefully. Okay, let me move this little rightwards because something is hiding this. Okay, yes, see, now you are having some allocations, right? Allocations are, this is one allocation, see here, this 100 is one allocation, 70 is 2, then third allocation, fourth allocation, fifth allocation, and sixth allocation. So number of allocations equal to, this is called number of non-negative allocations. Okay, so allocations equal to 1, 2, 3, 4, 5, 6. Allocations equal to 5. Okay, rows equal to m equal to, how many rows are there? 4 rows are there. Columns equal to n equal to 4 rows are there, and then again 4 columns are there. So you are having the value of m plus n minus 1 equal to 8. Sorry, m plus n minus 1 equal to 4 plus 4 minus 1 equal to 7. So what is the conclusion here? The m plus n minus 1 is, or you can write it like this, number of non-negative allocations. Number of non-negative allocations is not equal to m plus n minus 1. If they are equal, means the solution is feasible. Okay, if they are equal, means the solution is feasible. Otherwise the solution is not feasible. Okay, otherwise solution is not feasible. Okay, so now you have to write a conclusion. The initial solution is not feasible. The solution is not feasible. Okay, the solution is not feasible, which means the allocations is less than m plus n minus 1, right? Allocations is less than m plus n minus 1. So in order to make it as feasible, or in order to make it as what to say, you have to, there is some degeneracy occurs there. Okay, there is some degeneracy occurring there. The degeneracy is, this is called degeneracy. Degenerate. Okay, in order to eliminate the degenerate condition, we are going to add a small quantity. Okay, we are going to add a small quantity. So write that to resolve the degeneracy, degenera, degeneracy, add a small quantity epsilon that is approximately equal to 0. So we have to add epsilon. So most preferably you have to add this epsilon to the minimum value. You have to add this epsilon to the minimum value. So I am going to add this epsilon here. Okay, I am adding the epsilon here because why I have chosen this means already there are maximum of allocations in this row and maximum of allocations in this second column, in the third column, and the maximum of allocations are in second and third row. The minimum cost is throughout all the costs, the minimum cost is 0, 0, 0. So you can place this epsilon on any of the cost where the cell is unoccupied. You are not supposed to put epsilon here. If you put epsilon here means it is wrong. Otherwise you can put epsilon on any place on this 0 since it is minimum, or since it is minimum, or since it is minimum. Suppose if you feel like if you put epsilon here, what will happen means a closed loop will occur. If you put an epsilon here, what will happen? A closed loop will occur. If you put epsilon here, since there are already, see here, there is an allocation. See, there is an allocation. If suppose if I am having 0 here, if I put epsilon here, a closed loop will occur, which will create a problem in further solving of the transportation problem. So I have to put this epsilon in order to avoid the closed loops. If I put epsilon here, what will happen? A closed loop. You will get a closed loop because there is allocation. Here is allocation. If I put epsilon here, here is also an allocation. So there will form a closed allocation. So I don't want to form that closed allocation. I mean the closed loop. So I am putting the epsilon. Here. So if I put epsilon here means what will happen? Here the closed loop will not form. Okay, the closed loop will not form because there is no allocation here, right? So the closed loop will not form. Okay, so that can be avoided. Okay, your choice of placement of epsilon should be like that. Okay, so now you are having the allocations. Okay, now go to the problem. Now you are having the allocations. Now the what to say, how to calculate the cost. The initial basic feasible solution is formed by this matrix, and the cost is given by what cost is that? The unit cost. You have found that. So after finding that, you are going to check. Before that, how to calculate the cost also. So let us put the cost here. Okay, now you have all allocations. Now you have to check the optimal solutions. Okay, so before that, since everything is occupied, you can check whether the solution is optimal or not. If the solution is optimal means you can go with the next step. The initial transportation cost can be easily found. Initial transportation cost is given by, right, the initial transportation cost is given by 9 into 100 is 900 plus 3 into 70, 3 into 70, 9 into 100 is 300, 3 into 70 is 210. See, I am writing here 9 into 100 plus 3 into 70, then plus 6 into 20 is 120, then 0 into 30 is 0, 4 into 75 is 300, then 0 into epsilon is 0. So this is equal to 900 plus 210. So we shall add and write the answer. So 900 to plus 300 is 1200, 1400, 1500, 1530. Okay, 900 plus 300 is 1200, 1400, 1500, 1530 plus 0 epsilon. Okay, 0 epsilon. In some problem, if you are getting 1 here, means you will get 1 epsilon. That 1 epsilon means that will be equal to 1530. Here in the bracket epsilon tends to 0. Like that you have to write. Okay, 1530. In the bracket you have to write it as epsilon tends to 0. Like that you have to write. Now we shall check with the optimality. Now we shall check with the optimality. So not to check the optimality. Okay, if we check the optimality means the cost will vary. So that is what we are going to check now. This is simple initial transportation cost. So please keep in mind. Okay. Now here. Now in this you have to choose the cell with maximum allocation. Okay, you have to choose the cell with maximum allocation. So without considering the artificial allocation epsilon. Okay, the maximum allocation is in second row. That is 2 allocations are there. 2 allocations are there in second row. 2 allocations are in second column. 2 allocations are in third column. And 1 allocation is in fourth column. Okay. So first of all, the maximum allocation is appearing in second row. So I am choosing where the number of allocations are 2. So I am choosing here u2 equal to 0. Okay, u1, u2, u3 and u4. This is v1, v2, v3 and v4. Here u1 equal to something, u2 equal to something, u3, u4. Here since this is having maximum number of allocations, the first maximum of allocation I am putting it as 0. When u2 equal to 0 means what will be v1? v1 should be you have to see this value. Right? This value should be the sum of this v1 and u2. Since u2 equal to 0, this v1 should be 3. So the 3 plus 0 equal to 3. So this should be what? This should be 0 plus 5 equal to, sorry, this is actually 5. So that v2 plus u2 equal to 5. Here you should not write anything because there is no allocation. So wait for the next step. Here you are having 0. So that v4 equal to 0. Okay, since there is allocation epsilon. Okay, since v4 equal to 0, since 30 is an allocation, here you should get u3 equal to 0. So that u3 plus v4 equal to this value 0. Okay, now See here, since u3 equal to 0 and you are having allocation 6 here, this v3 equal to 6. This v3 equal to 6. Since v3 equal to 6 and you are having 9 here, okay, you are having 9 here, this u1 equal to 3. So that 6 plus 3 equal to 9. Okay, 6 plus 3 equal to 9. Okay. Now here you have to check once again. Since v2 equal to 5 and there is allocation 4, here you should have minus 1. So that you will have 5 minus 1 equal to 4. 5 minus 1 equal to 4. Okay. Now again, now you have to compute. Now you have to compute some of the dij values. The dij values means, okay, dij values means now we are having some column and rows values, right? Cij values. Cij, what are Cij? Let me tell you in words. These 5, 6, 9, 0, 10, 6, 7, then 6, 10 and 0. You are having these values, no? These values are called Cij values. Okay. What are Cij values? You have to write here. You have to write here. Cij values are 5, then the unallocated cells 6, then 0, then 10, then 6, 7, 6, 10 and 0. And uij, you know, ui plus vj. Ui equal to, you are having ui equal to 3, 0, 0 minus 1, then vj equal to 3, then 5, 6, then 0. So the concept here is you have to find dij such that dij equal to Cij minus ui plus vj. Cij minus ui plus vj. So here let us write that value. Okay, so you are having 5 here, you are having 3 and 3 here. 3 plus 3 equal to 6. 6 minus 1 is, sorry, you are having 6. 5 minus 6 equal to, this is 5. 5 minus 6 equal to minus 1. 5 minus 6 equal to minus 1. You are having 6 here. 3 plus 5 is 8. Okay, 3 plus 5 is 8. So 6 minus 8 is minus 2. Then here you are having 0. 0 plus 3 is 3. So 0 minus 3 is minus 3. Here you are having 10. So you are having 10 means 6 plus 0 is 6. 10 minus 6 is 4. Then you are having 6 here. 6 and you are having 3 here. 3 plus 0 is 3. 6 minus 3 is 3. You are having 7 here. You are having 5 here. 5 plus 0 is 5. 7 minus 5 is 2. Then you are having 6 here. You are having 3 here. You are having minus 1 here. 3 minus 1 is 2. 6 minus 2 is 4. Then you are having 10 here. You are having 6 here. 6 minus 1 is 5. 10 minus 5 is 5. So what are the dij values? The dij values are right here. The dij values are minus 1, minus 2, then minus 3, then you are having 4, then 3, then 4, then 5. Finally you are having 1 0, right? 0 minus 1 is minus 1. So 0 minus minus 1 will be plus 1. Okay. So you know the formula, dij equal to what? Dij equal to Cij minus ui plus vj. Okay. So these are the dij values. The dij values should not be negative. Please note that the dij values should always be positive, greater than 0. Okay. So you are having some conditions. I shall tell the conditions now. Suppose if you are having, if all dij is greater than 0 means the solution is the cost, the initial transportation cost, okay, initial transportation cost or current solution is optimum. Okay, suppose if all dij is greater than 0, or at least if all greater than 0 except only one dij, except only one dij equal 0 means 1 dij equal 0 means this is optimum and unique. Here initial transportation cost is not this is optimum, and alternate optimum cost will exist, or alternate solution will exist. Okay, alternate solution will exist. Suppose if it is not equal to 0 means, okay, suppose if it is not, is optimum, alternate allocation cost dij equals 0, initial transportation cost, the initial transportation cost is optimum, and an alternate optimum cost will exist. Okay, and if alternate optimum cost is existing means you are not required to find that alternate optimum cost. You can go with the initially find solution, right? It is only optimum, right? So it is optimum means you can write that solution. So that is rupees 15 something. What did we get? We have got some cost, right? Yes, 1530 rupees 1530. Okay, you can write that. Okay, but an alternate optimum cost for this will exist. It is the meaning alternate, and it is optimum. Initial transportation cost is optimum and an alternate optimum cost will exist. Suppose if you are having any of the dij, any dij less than 0, the initial transportation cost is not optimum, which means what is happening? Definitely this cost is not optimum. Okay, this cost is not optimum. Okay, since this cost is not optimum, this cost will be changed when you make the current solution as optimum means the cost will change. So in order to make it as optimum, you have to follow the following procedure. Okay, so once again, dear students, you are going to choose the which table. You are going to choose this table. Okay, you are going to choose, let me choose this table and that under this table. Okay, I shall choose both the tables. Okay, so that only you can easily understand. Control plus C, I shall paste it here. Okay, so paste it here, and I am going to choose the previous table also. Okay, the previous table also. Dear students, now in this we shall delete the unnecessary things. Okay, now you are having you are having on epsilon here. You are having an epsilon here that is missing in this table, so let us put one epsilon here. Okay, because actually we need to use this table. We need to use this table, but since there are some works done on this table, I am going to put the same table here. Okay, so here you can see the dij values. The dij values are what? The dij values you are having is -1, -2, and minus 3. So because of this only the optimality was lost, right? So in order to gain the optimality, you have to choose the maximum negative. You have to choose the maximum negative value. Okay, the maximum negative value is this minus 3. Okay, so let me choose this minus value. So where you are having minus, in a d4 you are having minus. So I am putting plus theta here. I am putting plus theta here. Okay, so let us choose some different color. Okay, I shall do this with a light blue. So I am choosing this minus 3. So I am putting plus theta here. I am putting plus theta here. Okay, so if I put plus theta here, then I have to draw the closed loop. Okay, the closed loop is from this plus theta to this allocation. Okay, so here I am going to put minus theta, and the next allocation is here. The next allocation is here. This is plus theta, and the next allocation is here. This is minus theta, and I am going to close this loop with plus theta. So this is the closed loop. Okay, now our task is you have to find the minimum of two minus theta values. So you are having one minus theta here, that is you are having the value as 100, and you are having another minus theta value as 30. The minimum of these two minus thetas should be considered. So the minimum of these two values is, here you are having 30 and here you are having 100. The value is 30. So you have to write that value. You have to write that value in the place of plus theta. In the place of plus theta, you have to write 30. Okay, you have to write 30. Now this is the allocation. Now this 30 is the allocation. Again, in the place of remaining plus theta, you have to add the plus 30 value here. So it will be 20 plus 30, that is 50. This is your second allocation. The 50 is your second allocation. Okay, so plus theta and minus theta. So you are having to minus theta, right? You have to subtract this 30 value from minus theta. So 100 minus 30 is 70 is your third allocation. Here you are having 0. 0 means there is no allocation. 0 means there is no allocation. Okay, now see again all the allocations. Okay, so this is 1, this is 2, and this is 3. 1 2 3 4 5 6, and you are having 7. You are having 7 allocations, right? You are having 7 allocations. So m plus n minus 1 is there. M plus n minus 1 is there. So now you can find a transportation cost. Now you can find a transportation cost. So before that, let us check with allocations. Let's check with allocations. So for 9 you are having 70, for 0 you are having 30, for 3 you are having 70, for 3 you are having 5, 4 you are having 75, 6 you are having 50, and yes, everything. Now since you are having number of allocations equal to number of non-negative allocations equal to number of non-negative allocations, number of non-negative allocations equal to, how many allocations are there? 7 allocations are there. 1 2 see 1 2 3 4 1 2 3 4 5 6 7 allocations are there, and also m plus n minus 1 equal to m plus n minus 1 is also equal to 7. So these two are equal. Since allocations equal m plus n minus 1, what will happen? Their existence, the solution, the cost is feasible. Okay, it is non-degenerate. The initial, this is the transportation cost. The current optimum solution, the current solution is the current solution, right? Like the current solution, current solution is you can write it as feasible, or you can write under non-degenerate. Okay, it is feasible and non-degenerate. Okay, it is non-degenerate basic feasible solution. Now you can find a cost. So the cost associated with this is, so 9 into 70. It is not necessary to find cost now, but let me explain what is happening from the initial transportation cost. Initially you have found 1530, right? Now we are going to find the cost for this. It is 9 into 70 plus 0 into 30 plus 3 into 70 plus 5 into 5 plus 0 into epsilon plus 6 into 50 plus 0 into 30 plus 4 into 75. So 1 2 3 4 5 6. How many allocations are there? Sorry, this 0 into 30 will not come. This 0 into 30 will not come because that is eliminated, right? That 0 into 30 will not come. That 0 into 30 will not come. So you are having, okay, 9 into 70 is what? 9 into 70 equal to 630 plus 3 into 70 is 210 plus 25 plus 0 epsilon plus 300 plus this 0 into 30 will come, right? So that 0 into 30 will come, that is 0 plus 4 into 75 is 300. That is equal to 600 plus 200 is 800. 800 plus 300 is 1100. 1100 plus 300 is 1400. 1430. 1450. Then 1450. 1475. 1475 rupees. You are getting the cost as 1004. You are getting 9 into 70, 630. Then just check 600 plus 200, 800. 800 plus 600,000, 400, 1400, 1430, 1440 plus 1465 rupees. 1465 plus 0 epsilon. Here epsilon will tends to 0, means you will get only 1465. Okay. Okay, now this transportation cost is what we obtained. So this is non-degenerate. Okay, so we have to check whether this non-degenerate basic feasible, this non-degenerate cost is feasible or not. This non-degenerate cost is feasible or not. Okay, so for that you have to choose this table. You have to choose this table. Okay, you have to choose this table. Okay, the remaining values are not necessary, so you choose only the table. Okay, control plus C. Now paste this here. Now okay, let us remove the remaining those thetas and something. Okay, you are just to have the allocations alone. Just have the allocations alone. Okay, if it is unallocated means just leave it. Because it will make you to get confused. Okay, this is the, now it is purely free from unwanted writings. Okay, now you have to check for the degeneracy. Okay, now you know, you can easily say what are the CIJs. CIJs equal to number of unoccupied cells, the values of unoccupied cells. So 5, 6, 9, then 10, then 6, 7, 0, then 6, 10, 0. These are the CIJ values, right? Unoccupied or unallocated cells. Okay, now you can say this is your U1, U1, U2, then U3, U4. This is V1, V2, V3 and V4. Now you have to check with the maximum number of allocations. So once again I am going to choose the second row. The maximum of allocations are in first row is also there. So if possible, let us choose with the first row also. Okay, so let me choose the first row because it is the first row with maximum number of allocations. So let me choose the first row. So U1 equal to 0. Okay, then if U1 equal to 0 means here V3 will be 9. Here the V4 will be 0. Okay, so if V4 equal to 0 means definitely the U2 will also be equal to 0 because see 0 plus 9 should be equal to 9. Yes, we got. Then you are having 0 is there, so 0 plus 0 equal to the value of AD4, that is 0. Now you are having the epsilon box, you are having 0, so the V4 plus U2 equal to 0. Since you are having 0 here, the value here is 5, the V2 should be 5. Okay, so that V2 plus U2 equal to 5. Please keep in mind Cij should be equal to Ui plus Vj. That is the thing. For allocated cells, for allocated cells. Okay, for unallocated cells you have to find Dij, that is equal to Cij minus Ui plus Vj. Okay, this is the concept. This is for unallocated cells. Allocated cells. Okay, now so you are having 5 here. Since it is 0, you will have 3 here. Okay, so since it is 9, U3 should be minus 3. Okay, U3 should be minus 3. Since it is 5, U4 should be minus 1. Okay, U4 should be minus 1. Okay, now you are having these values. Now you have to find the Dij values. So you know what are the Cij values, and Dij equal to Ui plus Vj. So these 5, okay, now you are having this Dij value, right? These 5, from this 5 you have to subtract 3 plus 0. 3 plus 0 means 5 minus 3, that is equal to okay, this is not visible. Okay, 5 minus 3 equal to 2, then 6 minus 5 equal to 1, then 10 minus 9 equal to 1, then 6 minus, see this is 3, minus 3 is 0, so 6 minus 0 is 6, this is 5 minus 3 is 2, that is 5, okay, 5. So this is 0 minus 3 means minus 3. So 0 minus minus 3 is plus 3. Here it is 3 minus 1 is 2, 6 minus 2 is 4. This is 9 minus 1 is 8, 10 minus 8 is 2. This is 0 minus 1 is minus 1. 0 minus minus 1 is plus 1. Okay. Since all the Dijs, what are Dijs? The Dij, I shall round the Dij values. The Dijs are 2, 1, then this one, then 3, then 6, then 5, then 4 and 2 and plus 1. So since all Dij greater than 0, the current solution, the current degenerate cost, the current feasible degenerate cost is optimum. The current it is degenerate feasible, right? Degenerate feasible cost is also optimum. So the total transportation cost is also optimum, not only optimum and unique. So this cost is already we have found, you know, the cost is what? 9 into 70. Okay, it is not necessary to write everything. 9 into 70, 0 into 30 plus 0 into epsilon plus 5 into 6 into 50, 6 into 50 plus 4 into 75, 4 into 75 plus 1, 2, 3, 4, 5. Remaining things are 5 into 5. 5 into 5 is there. 9 into 100, 9 into 70 is completed. Then 0 into 30 is completed. 3 into 70 is there. 3 into 70 is completed. 5 into 5 is completed. 0 into epsilon is completed. 6 into 50 is completed. Then 75 into 4. So that is equal to 680 plus 0 plus 0 epsilon plus 300 plus 300 plus 25 plus 210. Okay, the total cost is 600 plus 300, 900, 1200, 1400, 1430, 1430, 1440, 1465 rupees. 1465 plus 0 epsilon, that epsilon will tend to 0. Okay, or you can simply write it as rupees 1465. So in many of the textbooks you cannot find for this type of problem the initial transportation cost. When you want to, if you want to find the initial transportation cost, means the only thing is important. What is that? Means you should have number of allocations equal to m plus n minus 1. Okay, number of allocations should be equal to m plus n minus 1. That is enough to find the initial transportation cost. In the first step, you can see, first of all, you are not having this is a given transportation problem, this is not balanced. So in order to balance it, you are adding a column D4 with 0 entries, and you are adding the demand of 30 to it. Okay, so now it is becoming balanced with the total demand and supply as equal to 300. Okay, now you are applying the Vogels approximation method, and you are trying to allocate the transportations to each cell. So you are getting the number of allocations less than the value of m plus n minus 1. So this the feasible solution, it is not feasible, or this is not degenerate. Okay, this is degenerate. Okay, not feasible means this is degenerate. So you have to make it as feasible. So for that you are going to resolving that degeneracy, you are adding on epsilon. So after adding epsilon, you are getting the cost. Okay, you are getting some cost. Okay, the cost you have found there is yes, the cost you have yes, you are putting some epsilon there. After putting epsilon, you can see the number of, you can see what you can see, some dij values. Okay, at some dij values you are going to check whether it is optimum or not. Okay, so actually you are finding the cost here, right? The cost here is 1530 plus 0 epsilon. What I am going to tell here is, in many of the textbook, what they will do is they will not find the cost at this place. What place? When the epsilon, or sorry, when the dij's are negative, because it is obvious the cost is not optimum. Since it is not optimum, we should not find the cost. But why I have found the cost here? Because I want to make you to understand that this cost will change since it is not optimum, right? That is why I have found the cost here. Okay, you should understand that this cost will change. So actually, when can we find the cost? We can find the cost, initial transportation cost. Suppose if the question simply find initial transportation cost, means we will not go for all the checking of these things. Since when m plus n minus 1 equal to the number of non-negative restrictions, means we can simply go for the finding of cost in those problems. Okay, but when the problem question is asked like solve, means we are going to find the optimum cost. So we have found the dij values are in negative. So when dij's values are negative, means definitely the cost is not optimum. Okay, but we can find the cost here also. The cost here is 1530 plus 0 epsilon, and this cost will vary. Okay, why it will vary? Since it is not optimum, so you have to make it as optimum. So how to make it as optimum? So before that, when to find the cost? When the number of allocations are equal to m plus n minus 1. Number of allocations are what? Here you are having 101, then you are having 2, then okay, So what I'm telling is when m plus n minus 1 is both these two are equal, you can find, right? So now you are putting one epsilon, and you put epsilon means what will happen after putting epsilon. See, after putting epsilon, see number of allocations are 1, 2, 3, 4, 5, 6. After putting epsilon here, number of allocations are becoming equal, right? So number of allocations are equal means you can find, okay, so you can find the cost. But in many of textbooks they don't find this cost because they know it is not optimum. So it is not required to find the cost here, but keep in mind now the cost is 1530. The cost is 1530. After this cost is not optimum, right? So we have to make it as optimum. So how to make it as optimum? You are having the maximum value, maximum negative value in AD4, that is minus 3. You have to remove this negative, means all negatives will be obviously not considered, will be automatically removed. So you are going to put plus theta for this, and after the next allocation will be minus theta. The closed loop, you are going to make a closed loop with the nearby allocations, with the neighboring allocations. So we are putting the allocations on these 4 places, and after that, okay, after that you have to put this 0 is 30, this theta means you have to choose the minimum of 2 minus theta values. One is 30 and another one is 100. Minimum of 130 is 30. So you are putting the 30 for the first plus theta 30. On the next for the remaining plus theta you have to add that plus 30, and for remaining minus thetas you have to subtract that minus 30. Okay, so 100 minus 30 is 70. It is 30 minus 30 0. When the allocations becomes 0 means there is no allocation. Okay, so you should not put the allocation there. It is simply 0. Okay, now you are getting the remaining values. For this you are again applying the values ui and vj's. You are calculating ui and vj's, and after that you are calculating daj's. In this all daj's are greater than 0. So you are getting the optimum cost. The optimum cost here is 1465. Okay, but actually where did I have find the cost? Actually without testing the values. Here m plus n minus 1 are equal, right? M plus n minus 1 is equal. So here itself I have found the cost. Here itself I have found the cost. The cost is 1465. Okay, so I am going to check with the daj values. The daj values are also coming positive. If daj is a negative means what will happen? If daj is a negative means definitely this cost is not optimum. If daj's are all greater than 0 and at least one d and only one daj is equal to 0 means again I am going to write the same cost. Again I am going to write the same cost. The cost is rupees 1465, and I can also write alternate optimum cost will also exist. This is the cost. Okay, for my procedure alternate cost will also exist if someone follows some other procedure. Okay, but in this procedure, in this problem, all daj's are greater than 0. Since all daj's are greater than 0, I have found one previous cost, right? That cost is not only non-degenerate, not only basic feasible, it is optimum and unique. It is optimum and unique. So the cost is 1465. The cost here is 1465. Okay, so the problem is very important. So in many of the textbooks the people will not find the cost at this place. Okay, so in the examination also when the question is asked like solve means it is not necessary to find the cost at this place because this cost is subject to change. But it is not like it is not possible to find cost here, because what is the minimum requirement to find a cost? It is not daj's. Daj's are only to find whether it is optimum or not, or it is optimum and unique, or it is not optimum, or only 3 conditions, right? What are 3 conditions? Whether the given cost is not optimum or not. Given transportation problem, the given problem is having some solution, whether the given solution, whether found out solution is optimum or not, or it is optimum and unique, or it is optimum but some alternate solutions will also exist or not. These are the conditions, right? But to find the cost, when can we find the cost? When m plus n minus 1 is equal to number of non-negative allocations. So you can allocate the transportations from A to D3, B to D1 and B to D2 also can be allocated. The cost is allocated with A equal, I mean n, then B equal to BD3, that is BD3 equal to 3 and D2 equal to 5, like that you can allocate. So for this you can also write the allocations. Allocations can be written as, the allocations can be written as see, I can write allocations here. Allocations are x11, sorry, this is 1 2 3 4, 1 2 3. So this is, I am putting everything as see here, okay, x11, x12, x13, x14, then it is x21, x22, x23, x24, this is x31, x32, x33, x34, this is x41, x42, x43, x44. So x13 equal to 70. These are allocations. Then x14 equal to 30. Then x21 equal to 70. Then x22 equal to 5. Then x24 equal to epsilon, artificial allocation. Then x33 equal to 6, so it is 50. Then x42 equal to 75. Okay, number of allocations are 1 2 3 4 5 6 7. Okay, these are the allocations. Okay, you can also write it as AD3, AD4, like that, BD1, like that also you can write. Okay, no issues in it. Okay, so this is the procedure of solving the problem. So thank you all for watching this problem. I hope you can solve any problems in transportation problems category. So let us meet with the next superb problem on next class. Thank you all for watching this video. Thank you once again.